So hi everyone, my name is Brian O'Connor. I'm here with my colleague Reshma Sudarshan. We're both from Intel, and here we're going to be talking about PINs, which is the P4 integrated network stack. There we go. So what is PINs? PINs is basically, we took Sonic and we added SDN to it. So why Sonic? Sonic's widely deployed, modular, open source, and vendor agnostic. It runs traditional network control protocols like BGP, and it's a solid foundation for what we thought to be an SDN-enabled SwitchOS. It comes from Microsoft. It's got tons or millions of ports in production, and it's got a huge following both on the operator side and the vendor side. So what about SDN? SDN is software-defined networking. It's a technique that we've been using for a little bit over a decade now, which rethinks the way that we develop control planes for our networks. SDN brings a lot of features and capabilities to the network, which may be difficult to achieve using standard traditional embedded control plane protocols. So we put these together to create PINs, or P4 integrated network stack, to add SDN to Sonic. And the two big ideas I want you to walk away from this talk today with in your mind are we did two things, really. The first is we added a formal specification of the pipeline, the PSI pipeline, in P4. And the second is we added a remote API, which is P4 runtime, which allows us to program the PSI objects from a remote controller. So let's just talk a little bit about what the benefits you have when you take Sonic and add pins to it. The first is you get optionality. So network operators have a choice about what goes where now. You don't have to run everything on the box. You don't have to run everything using an in-band management network or an in-band control plane. We're building on PSI, so you still get optionality from a vendor perspective. You can run this on Broadcom, Intel, Cisco, Marvell, NVIDIA, and other ASICs without changing the SwitchOS or really even changing your programming model. What PINs is providing is an abstraction that translates between P4 entities, or the P4 abstracted entities of the pipeline, to PSI API calls. And so at your control plane now, you don't have to think in terms of PSI or a PSI API. You think in terms of the pipeline that's been programmed in P4. And then the other thing we've added to Sonic is a response path. Oftentimes in Sonic today, it's sort of a fire and forget. The control plane makes a decision, hopes that it gets realized at some point, and then Sonic kind of drives the program eventually towards a consistent behavior. But in SDN, that doesn't work so well. And so what we've added is an ability to propagate back errors and propagate back information about when the rules are actually programmed. And then finally, we've added remote packet I/O. So if you want to implement an ability on the box to send and receive packets, this is required to implement some control plane protocols, like maybe DHCP, or if you wanted to do some DNS sniffing. We can do that over P4 runtime as well. So to round out our overview, then this is a bit of an eye chart, but if you're familiar with Sonic, it probably looks familiar. We start at the bottom with our syncd container. This is where the vendors provide their libSci implementations. We work up to our ASIC database. This is where we get the PSI objects. And then moving up the stack, we have our switch state service, which is the middle layer there. We've added a P4 orc. That's what does translation between PSI calls and our P4 calls. We've added some new tables for our P4 runtime or P4 entities. And then we've also added a response path where when entries get installed, we get a notification, and then we can propagate that notification up to the control plane. We've only added one new app to Sonic to make this happen, and that's our P4 runtime server, which is what talks to the remote controller. So hopefully this provides a little bit of an overview of what we've done with the PINs program. And next I'm going to turn it over to Reshma to talk about some of the extension capabilities we have with PINs.
Thank you, Brian. With the aim to extend the existing standard PSI pipeline, we have implemented the generic PSI extensions that adds the new infrastructure in Sonic to realize novel features by adding additional match action tables into the SI pipeline. This gives user the flexibility to extend their existing SI features or protocol or add proprietary IP in their applications that they want to write in the secure environment of Sonic pins. At the same time, have a uniform management interface across all their applications as well as all the devices in their network. The users assume the underlying SI pipeline as their baseline and want to create new tables as touch points to extending SI features. These new tables, just by adding a couple of them in certain places in the pipeline, and they're programmed in a way that is independent of the data path. These extension tables can change the metadata that is used in the pipeline, or they can create new metadata that is not used in the pipeline's regular flow. Recalling the pins architecture in Sonic, we propose these enhancements to have a more generic way to program these extension tables. The P4 runtime container, as you see, intercepts the P4 info messages from the controller and add the match action fields of these extension tables into the application database. In addition to this, it also creates a table definitions database to record the intertable object dependencies. The P4 org, as you are aware, that we added in pins last year, now has a new extensions table manager that processes these tables from the application DB and creates the dependency graph. Firstly, it creates the object type key value pair for the dependent object and looks up the associated cache to be able to program the ASIC DB by making the SI API calls. This is an example that we have in the demo in the Experience Center at this time. As of last week when we created this presentation, we didn't have the double VLAN tag extension in the Sonic SI. So if a user wants to create a new table, they would add something like the red table that is depicted here. The yellow boxes depict the fixed tables, and of course, ACLs, etc., that were added in pins last year can be varied at runtime. So by adding a couple of such extension tables as this decap double VLAN table that you see here, we can realize a new feature from the user point of view, and that's applicable to any ASIC that I know that's there out there today. So please come to the Experience Center and see our demonstration of this feature using the double VLAN tag decap. Thank you, and open to any questions if you have. Thank you. We'll see you in the Experience Center.